3.3. Now we're going to work on graphing inequality solutions. So the first one's actually pretty easy. It's already set up. So the first equation we're going to highlight in yellow. Y is less than 2x. So our y-intercept is 0. Our slope is positive 2. So up 2 over 1. Up 2 over 1. It's a dotted line. So I'm going to draw it by hand. Okay. And it says y is less than. So we're going to shade below. We're going to use yellow since that's what I marked it with. We're going to shade below. Alright, easy enough. Now, let's do the second equation. Y is greater than or equal to negative x plus 3. So I have a y-intercept of 3 and a negative 1 slope. Okay, that's a solid line, so I can use my little graph, my little line tool. And it says y is greater than, so we need to shade above it. Okay. So as you can tell, the green area is going to be the solution set that satisfies both equations. And you can shade a little bit more over here if you need. So everything in the green represents the solution for both. Okay, going on to the next one. Okay, number 10. Y is less than or equal to 3x plus 1. So I have a y-intercept of 1, a slope of 3, up 1, 2, 3 over 1, up 1, 2, 3 over 1. Okay, 1, 2, 3. So we can plot this. Fortunately for us, it's a solid line. So there we go. And it's shaded below. Y is less than or equal to. Alright, the next equation isn't set up in slope-intercept form, but not a big deal. All we got to do is set it in slope-intercept form. So let's look at it. So negative 6x plus 2y is greater than 5. So let's add 6x to each side. So I get 2y is greater than 6x plus 5. Divide everything by 2. Y is greater than 3x plus 5 over 2. So I have a y-intercept of 2.5 and a slope of 3. So we go up 3, 1, 2, 3 over 1, up 3, oop. So down 3, 1, 2, 3 over 1, down 3, 1, 2, 3 over 1, down 3, 1, 2, 3 over 1. Let's graph it. What do you notice? It's the same slope. It says y is greater than. So it would be above this. Nah. So if they never intersect, no solution. Okay, next example. Number 18. And you could have been able to tell right here. The slopes are the same, by the way. Okay, number 18. Y is less than 4. So my y-intercept's 4. It's a dotted line, so I'm just going to draw a dotted line at 4. And y is greater than, so we're going to go yellow above. My next equation is y is less than the absolute value of x minus 1. So we can find the vertex at negative b over m comma c. My b value is negative 1. My m is 1. My c is 0. So my vertex is negative times a negative is positive, so 1 comma 0. So there's my vertex. And my slope, because my parent function is just y is greater than or less than the absolute value of x, so here we go. It's going to be a slope of 1 and negative 1, dotted of course. And it says y is less than. So basically everything outside above x equals 4 and to the underneath is our solution set for number 18. All right, number 24. 2x, negative 2x plus y is greater than 3. So let's first graph that one. Let's rewrite it over here. Negative 2x plus y is greater than 3. Let's add 2x to each side. We get y is greater than 2x plus 3. So my y-intercept's 3. My slope is positive 2, so up 2 over 1. Up 2 over 1. Okay. So we're just going to do a dotted line. I missed the graph a little bit. It says y is greater than, so we're going to shade above. Alright, we're just trying to get a good idea what's going on here. The next one, y is less than or equal to negative x plus 4. So we know we can also solve this way. Y is less than or equal to negative x plus 4. So our vertex is negative b over m comma c. Negative, our b value is 4 over m, which is 1. Our c value is 0. So our vertex is negative 4, 0. So here's our vertex. And it's going to have a slope of negative 1. And it's a solid line because it's less than or equal to. And so what do we notice? It's less than, so we're going to shade this area. Alright. Easy enough on this. That is it for section 3.3.